Hi, I had example 3 from the torque problem set from Expert TA. It starts off by saying, suppose you exert a force of 170 in tangential to the outer edge of a 1.505 meter radius, 74 kilogram grindstone, which is a solid disc. A says, what is the torque in Newton meters you are exerting on the grindstone relative to the center of mass of the grindstone? So first I started off by drawing out the solid disc. Um, then I started labeling it due to the values above that I was given. So um, you know that the force will be 170 Newton. The distance of axis rotation would be 1.505 meters, and the overall mass of the solid disk is 74 kilograms. So starting off, you would write a equation down for the values that you were given above. So you would have torque is equal to the force of the perpendicular lever. So then you would add in your values. Your F would be 170 Newton, and your perpendicular lever would be 1.505 meters. This will give you 255.85 Nm. Moving to the next question, it states, what is the angular acceleration of the grindstone in radians per square second, assuming negligible friction? So, starting off with this question, you would have to find the equation and do a little bit of algebra to find the right equation to actually put your values into. So that is what I did here. For this question, you would need to know the moment of inertia. So with that in mind, you would just break down the equation and come up with your overall equation of 2F divided by mr. So then you would plug in your values, 2 times 170 newtons divided by 74 kilograms times 1.50 meters. This will overall get you your value of 3.0528867 radians per square second. Next, moving on to the third question, letter C, it states, what is the angular acceleration of the grindstone if radians per square second if there is an opposing frictional force of 19.5 newtons exerted 0.45 meters from the axis? Starting off with this problem, we have already um, have two torques, this one here, and then this one over here. And so we would have to rearrange this equation to make it usable. So then we would take this equation right here from the one above, and this would be the equation that we use. This equation would be the force times the acceleration of the perpendicular lever. And then, so it says that it should have a new frictional force, opposing force. So I will go ahead and try to draw it within the solid disk above. This would be right about here. This is the opposing, and it would equal the 0.45 meters. This means that it is going to rotate this clockwise. Let me get this perpendicular first. So this means it's going to rotate clockwise. This would be called F sub F, and the value was given above. It is 19.5 newtons. So with the equation, you're going to do 170 newtons times 1.505 minus 19.5 newtons times 0.45 meters. And then you're going to divide that whole equation by 74 times 1.505 squared divided by 2. And this will overall get you the answer of, this would get you the answer of, wait a minute. Okay, now that I have the right color, this would get you, after doing this equation and typing this in your calculator, this would get you 2.95683.239. And this would be in radians per square second. So it's just going to be rad divided by square. And there you have it.